Hello guys and welcome to Datum Learning. On this channel we talk about data and everything related to it. So today's topic is feature selection, and I think it's one of the most important topics in machine learning because it helps you in two ways. One, it helps you reduce the training time, and second, it helps you overcome overfitting. So we are going to discuss both of them in this lecture, and yeah, let's get started. So what is feature selection? Basically, there are only two steps. One, when you're given a data set, you need to choose some features out of the data set and you need to delete them. That's it. Choose some features, delete them. And an additional benefit is also there that you get to rank the features. So you can rank the features according to the importance or coefficient based on when it comes to importance. We'll be using some tests which I'm definitely going to show you in this video. So just hang on and you can rank those features yeah, on the importance. Yes, so yeah, the tagline for this video or this whole feature selection is less is more, and this is very much relevant to the topic because less signifies less noise and more signifies more information. Let me explain. Actually, what happens when you get a real world data set, it's a lot of features, maybe like most of the time it's a lot of features and a lot of training data, and it has been observed that almost all of the data sets that you get contain some columns that are more noise than information, and it is very much understandable to remove those columns out of the way so that we get a lesser a smaller data set which actually fits better, which actually helps the model fit better to the information and not the noise. So always remember, when we are talking about feature selection, we are trying to lessen the size of the data set, and that gives us more information. Why? Because we are reducing the noise. That's why less is more. Okay, less is more is fine, but why do we need to do that? And the reason is quite simple, which I'm going to explain right now. Supposingly you've got a data set, and right now I'm showing you the problems of not doing feature selection, because you need to understand why you are doing feature selection before doing feature selection, right? So okay, you are given a data set, and to a normal eye, to someone who is even familiar with machine learning, will think, okay, this is some kind of a small data set with no problems at the first glance. But if you look closely, the column D is related to column B. Actually, let me tell you, column D is nothing but column B plus 0.2. So here we have 2.5, so it is 2.3 plus 0.2, and same applies to 1.1 plus 0.2, 9.4 plus 0.2 is 9.6. So all the elements of D are actually dependent on B, or rather you can say they are collinear. What collinearity means in this case is y equal to ax plus b, and in our particular data set a is equals to 1 and b equal to 0.2. So yeah, you can see that the column D is collinear to B. The second problem that exists most of the time is of actually less variance. What you can clearly see that this particular row is all one. Now you are given a dataset that you download from Kaggle or UCI repository, and you encounter a feature which is all one, or maybe I add a column that is all of similar value, all values are same. Do you think it adds any information to your dataset? Obviously no, because anyone can do that. And obviously it does not add anything to the no information is added, because even it's there, it's useless. So columns like this needs to be removed. Now you will never get 1 1 1 1 1 all the time. Why? Because there is some noise, so you'll get 1.12, 1.1, 1.02, 0.98, but very very close to 1. That even though it's not equal to 1 and you'll not be able to see directly, it will still have very less variance, and that's why it's totally irrelevant. And the problem that these columns have is less variance. So if your column, if your feature has very less variance, okay, column equal to feature, just keep that in mind. So if a column has very less variance, it's irrelevant. Number one, collinearity. Number two, less variance. And the third problem is most widely encountered and is the most difficult to understand. Now the if you look at this data set, it will look clean, okay, it will not have any problem, and trust me, nobody will be able to get it, because if you, again, the problem lies in the column D. Column D is actually, I have generated it with my, first is my age, 21, second, July 1998, that's my date of birth. This one is my height, 5.9, and I weigh 65 kgs. Now to anyone on this world, this particular column will look normal, but this is definitely irrelevant, right? Now, when you download a data set or when you get a data set, you don't know which one is relevant, which one is not relevant. So the thing is, uh, you need to have a method that will help you find those irrelevant columns and remove them, and that is our goal. So I think the three problems are totally discussed, and the best part of this column is it has no collinearity and it has some variance. So there is no possible way in which you will be able to identify, doesn't matter how much what to say you are trying to find the variance or checking the collinearity. So this is one problem that exists a lot, and this is where we are going to focus most of our video on. Okay, so why bother about irrelevant features? Because the question is, when you are given a data set, you train a model, right? So when you train a model is supposed to know that this particular column here is irrelevant. So the coefficient f of d, like if small a, small b is these numbers that we put in, and f of a, f of b, f of c are the coefficient that the model learns. You expect that after training, f of d should be so small that whatever d is, it doesn't matter. Or in other words, you want it to be equal to 0. The f of d you want to be equal, you want it to be equal to 0, not d, and that will make the column d totally irrelevant, and your point is correct, but there's still a lot to lose. Why? Number one, training time. In order to understand, in order for the model to learn that f of d equal to 0, it needs to be trained. And if it needs to be trained on a large data set having many collinear or less variance column, or even the third problem which I said of useless values, there has to be a lot of time spent in order to figure that out, and that is one big problem. You'll require a lot of training time in order to understand that these are irrelevant. Second problem, simpler models are easier to interpret. What happens is when you have these features removed, you'll have only three features, only two features. Your number of features will reduce drastically. That will actually help you in order to interpret. How? You'll be able to draw more graphs, because, and in simple words, if you have less numbers, you have less complexity. Makes sense, right? And the third is the most widely discussed problem. It reduces it actually the feature selection actually removes, or rather reduces, overfitting. Now how it overfits is going to be my next slide, and it's going to be very important, because this is the main problem, right? Overfitting. So you had a data set and you thought that your f of d will be equal to 0, and it will make this column irrelevant. Fine, accepted. But what happens if you have, and yeah, there's one more thing. Training and coming with a value equal to 0 is not possible, because for that you'll require a very large data set, which very large data set, like, and you'll never get that, obviously, because there is a limit to everything. So you'll never come equal to 0. You'll come approx, f of d equal to 0, not d equal to 0, I'm sorry, f of d equal to 0. You'll come approximately come to f of d equal to 0. Just check this one. Okay, so what will happen if there are large number of irrelevant features? You'll definitely have a problem. Why? Because f of d equal to 0, then you'll have f of d, f of e, f of f, f of g, so many irrelevant columns whose coefficients, even though are almost equal to 0, but when they will add up, they will add up noise. Now let me explain why they will add up noise, and this is important. You see, d is dependent on b, because we could derive d from a linear equation of b. So d is not adding any information, fine, but it is definitely, and b column means d is not adding any information. Till now we are fine. And b, any column in this world, okay, when in the data set, they have some kind of a noise, right? So even column a will have some noise, but it will have more information. B will have some noise but more information. C will have some noise but more information, but because they are relevant features. But what about d? It is adding no information, because whatever information it is d is adding is already added by b, but what it has is noise. Whatever noise b was having, d also has. Now if you consider a lot of features, collinear features, for the first case also, they will have a lot of noise, right? Because they have derived their noise from different columns, and no added information, because the information was already added before. So this is how a column or a model overfits, because overfitting is basically Overfitting is basically a model trying to learn the noise. I'll explain overfitting and underfitting in great detail with a lot of visualizations in my next video, and so please just hang on. And this particular video ends here, but the next video I'll actually show you the ways of overcoming collinearity and less variance, and we'll continue with this same topic in the next video. Thank you, and please subscribe and hit notification, because there are a lot of times when people actually skip through their doubts, because they go online, they don't get the answer, so they say, okay, next time I'll just whenever I come across the problem, I'll search next time. So if your notifications are on my channel, what will happen is, definitely I'm sure that whenever I'll make a video, I'll definitely make a video which has something to do with your doubt. Okay, so your doubt will be instantly cleared, and that's why I think you should subscribe to my channel. Okay, thank you.